Hi, today we're going to be doing electrical circuits. First we're going to start by talking about each component of a circuit. So we're going to draw a little one right here. Okay. So first we have the voltage, which is basically just the force to move the electrons. Okay, because they're moving this way throughout the circuit, and it is measured in volts, just V. And we have current, which is just the rate of the flow of the electrons. It is measured in amperes, just A. And then we also have resistance, which inhibits the flow of electrons. And it is measured in ohms. Which is this. Okay. And so we have the formula, which is, just love this. Okay. We have the formula, which is V equals IR. So V is the voltage, I is the current, and R is the resistance. Okay. So if we take this down here, draw again. Like this. Okay, so they give us the volts and the resistance. So we want to find the current. Okay, we don't know what the current is. So we're going to use this formula. Use this formula to help us find the current. Okay, so we're going to set up the formula. V equals IR. And we want to find I. So we're going to isolate it by dividing both sides by R. Get I equals VR. And so in order to solve, do I equals the voltage, which is 12, divided by the resistance, which is 6. So the current is going to be 12 divided by 6, which is 2. So it's going to be 2 amps. Okay. Okay. Now we're going to do a different one. We're going to do one with That's what we're going to do one with multiple resistance. Okay. So the voltage is going to be 12 volts. R1 is going to be 0.3 ohms, 0.6, R2, R4, 1.2, 6.3. Okay, and so we don't know what I is, the current, so we're going to find that. And so we're going to take the formula again. And since we're finding I, we're going to divide both sides by R to isolate it. And this time, since there's more than one resistance, we're going to have to add them. So it's going to be I equals V over R1 plus R2 plus R3 plus R4. So it's going to be 12 divided by 0.3 plus 0.6 plus 1.2 plus 6.3. Okay, and if you do that out on your calculator, you should get 1.43 amps. Okay, let's do a different one. But this time, oh, wait. This time we're gonna look for the resistance. Okay, so the voltage is 120, R1 is 2, R2 is also 2, R3 is 1, and we don't know what R4 is. We know that the current is 10 amps. Okay, and since we're looking for the resistance, we're gonna do V equals IR. Looking for resistance, we're gonna divide each side by I. So if R equals VI. Now we're just gonna format it like usual. We're gonna do 2 plus 2 plus 1 plus, and we don't know what it is, we're just gonna say X. I'll just say 4. And we know that it's equal to 120, which is the voltage, divided by the current, which is 10. So we're gonna have 2 plus 2 plus 1 is gonna be 5. So 5 plus R4 is equal to 120 divided by 10 is 12. So 5, we're going to have 5 plus R4. And now in order to find R4, we're just going to subtract 5 on both sides. Now that R4 is 7 ohms. That's your answer. Okay, now this one we're going to try to find the voltage. Okay, now the current is 12. And first resistance is 2, R2 is 3, R3 is 4, and and R4 is 1. Okay, we're looking for the voltage. So V equals IR. And it is already formatted correctly, so we can just leave it as is. We can go over here, so we know that V equals to I, which is 12. And we want to do plus R, so we're going to add up all of them. 2 plus 3 plus 4 plus 1. So V equals 12. 12 times 10. The voltage is 120 volts. And that is your answer. Okay, moving on. Let's see. Okay, so if the current is reduced by 2, what is the effect on the resistance? Okay, so we want to format our equation equals IR, and the question is looking for resistance, so we're going to isolate the R. So we can say V equal to V I. V over I. Okay. And it says the current. So if the current is reduced by a factor of 2, so it's going to be 1/2, this is being reduced. We're gonna replace the I with 1/2, so R is equal to V over 1/2. And I like to turn the V into an I, just so it makes everything turn the V into a 1, so it makes everything easier. Okay, if we do 1 divided by 1/2, it's the same thing as doing 1 over 1 times 2 over 1. So that's going to be 2. So the resistance is going to be doubled. Okay. Okay, now let's do let's go into series and parallel circuits. We're going to start off with a series circuit. Series circuit. The formula is still going to be the same. P equals IR. Okay, so I'm going to draw this out. Okay, so we want to find the resistance, voltage, and the current for each part. So in this occasion, we're going to have RT is equal to R1 plus R2 plus R3. For the current, it's going to be the same throughout the circuit. So it's going to be I1 is equal to I2 is equal to I3. And the voltage is going to be V1 plus V2 plus V3. So let's start with the resistance. So let's see, RT. RT is all of them added up together, so 17 plus 12 plus 11 is going to be 40 ohms. We want to find the current, total current, which will be the same throughout. And we want to find the voltage for each part. We know the total voltage is over here, which is 60. Okay, and so we know that V equals IR, and over here we don't know what I is, so we're going to divide both sides by R. So I is going to be the voltage, which is 60, divided by 40, and you should get 1.5. So since the total is 1.5, the rest of them should also be 1.5. And so now we want to find each part, and we already know R1, R2, and R3 from the circuit shell. So now it's 17, 12, and 11 from all these numbers. Okay, and now all we need to do is find the voltage. So for that we can just multiply I times R to get the voltage for each part. So first we're going to do 17 times 1.5, and we'll get 25.5. Then we're going to do 12 times 1.5, we should get 15. And we should do 11 times 1.5, and you should get 16.5. And that's how you do a series circuit. Okay. Now we're going to do a parallel circuit. Okay, now we're going to do a parallel circuit. They look like this. And they also use the formula V equals IR, but there are some things that are different. So for the total voltage, it's going to be the same for V1, for V2, and for V3. So it's going to be the same throughout. For the current, it's going to be the sum of all of them. So it's going to be I1 plus I2 plus I3. For resistance, the total resistance is also going to be the sum of all of them, but it's going to be 1 over R1 plus 1 over R2 plus 1 over R3. Okay, let's try an example. There's one more. Okay, the total voltage is 400, R1, R2, R3, and R4. So they're going to be 60, 20, 15, and 30. So let's set this up. First we want to find out the total resistance. So RT is equal to 1 over R, 1, 2, 3, 4. So 1R, 1, 2, 3, 4 is equal to 1 over 60 plus 1 over 20 plus 1 over 15 plus 1 over 30. You should get about 0.167. And so you want to put that over 1. So it's going to be 1 over 0.167. And you should get about 6. So now we know the total resistance for the circuit. Let's set up the table. V3, V4. We know the total is 400, and we will find out the rest later. IT, we don't know any of the currents, so we're going to have to calculate those. And then the resistance. We just found out that the total resistance was 6. And we know R1 is 60, R2 is 20, R3 is 15, and R4 is 30. Okay, so we want to calculate for I, right? And we know that the voltage is the same throughout. So it's going to be 400 throughout the circuit. Now all we need to do is find out the I's. So we have V equals IR, and we want to find I, so we'll divide by R, and we'll get I equals V over R. So we're just going to do that for each one. So we're going to do, so to find I, we're going to do 400 divided by 6, we're going to do 400 divided by 60, and so on. So we're going to do 400 divided by 6, which would be 66.67 amps. We should do 400 divided by 60, which is 6.67 amps. 400 divided by 20, which is 20 amps. 400 divided by 15, which is 26.67 amps. And 400 divided by 30, which is 13.33 amps. And so that's how you do it. And finally, we're going to do a combination circuit, which is basically a combination of the series and parallel circuit. So it's going to be both together. And here is an example. So for these, you're just going to do however you would for each one, and then just combine them at the end. Okay, so the total voltage is 300 volts, R1, R2, R3, R4, and R5. So R1 is 10, R2 is 20, R3 is 30, R4 is 20, and R5 is also 20. And so first, we're going to do the parallel circuit first. And if you go up here, we can see that we want to calculate the resistance first. So we're going to do 1 over R1. So we're going to take all of these, and we're going to add up. So it's going to be the total resistance is going to be 1 over R3, 4, 5. So it's going to be 1 over R3, 4, 5 is equal to 1 over 30 plus 1 over 20 plus 1 over 20. Okay? And you should get 0.13. So then we're going to do 1 over 0.13. You should get about 7.5 ohms. So that's your total resistance. And now you want to redraw the circuit. So now we're going to draw it like that. Just the same as before. But this time, going to be 7.5 because it's the combination of these three. This is still 10, and this is still 20. This is R1, R2, and now this is called R3, 4, 5. Voltage is still the same. Okay, and now we are going to make a table out of this. So we're going to do VT, V total, V1, V2, V3, 4, 5. And since this is a series, the voltage is not, this is now a series, we turn the parallel part into the series part. So now this will be different voltages for each section. However, the current will be the same throughout. So once we figure that out, it'll be the same for each. And we already know the resistance. Okay, and if we add 20 plus 10 plus 7.5, we will find out that the total resistance is 37.5. R1 is 10, R2 is 20, and R3, 4, 5 is 7.5. We know the total voltage is 300 volts. And now we are going to calculate I, as well as the remaining voltages. Okay, so V equals IR. We're looking for I, so we're going to divide by R. It's going to be R equals, no, I is equal to VR. So in order to find total, we're going to do V divided by R. So we're going to do 300 divided by 37.5 to get R. So we should get 8 amps. And since the current is the same throughout, each one is going to be 8 amps. Okay, now all we need to do is find out the voltage. And so the equation is V equals IR, so we just have to multiply I and R. So 8 times 10 is going to be 80 voltages, 8 times 20 is going to be 160 voltages, and 8 times 7.5 is going to be 60 voltages. And if you add them all up, it should be equal to 300. And yeah, that is how you do electrical circuits.